In the last lesson we learned how to enumerate or iterate an array, and to do this we used a block method. Well, block methods for arrays can be used for a whole variety of other things, including sorting, mapping our array values, or even different kinds of iteration. We'll learn a little bit about those in this lesson. Let's start with find. Sometimes it's not sufficient to just get the square bracket operator to find an element in an array. Sometimes we might need to use some more complicated logic to determine which element we want to retrieve. Imagine we want to find the first word in a string whose first letter is an O. We can call the find method on our array of strings and pass it to a block using the do and using the pipe symbols around a block argument called tree. Then inside our block, we're going to define the conditions for finding that element. In this case, I just want to look at the 0th, in other words, the first element of the word. So I'm going to say tree 0 equals equals, recall our equivalence operator equals equals, to O. And then to close the block, call end. When I run this code, the result is olive. That's the value that's returned by the find method. If I want to return all of the matching elements of that condition, I can use now select. Select, instead of returning a single element, will return an array of elements. So if there are multiple matches, I'll have an array containing those matches. If there are no matches, I'll end up with an empty array. And it's important to note, if there's only one match, I don't get that element. I get an array containing just that element. So note that I always get an array. I can use a block to do something to each one of the elements in my array. This will give me a new array with the original elements of the array somehow modified. This is called the map method. Imagine that we're mapping one set of array values to another set of array values. In this case, I want to generate a new array, which is all of the original values of my array, but converted to uppercase. To do that, inside my block, I'm going to use the .upcase method. In the previous lesson, we learned about sort, and we mentioned that sort sorts the elements in an array lexicographically. Remember, that's numbers first, then capital letters, then lowercase letters. But what if we want to sort by some other condition? We can do that with a block. In this case, I actually need to pass two block arguments. This is, say, A and B. And the code inside my block defines how those two variables should be compared. Let's imagine I want to sort not by the lexicographic order of the strings in my array, but rather the length of the strings in my array. In this example, I'm using the comparison operator. It's a special operator that allows us to get a quick idea of which object is bigger out of a pair. If the objects are the same, I get the result 0. If one object is larger, I get 1. If the other object is larger, I get -1. When we call sort on its own, sort uses the comparison operator to sort our objects lexicographically. In this case, we're going to use the comparison operator ourselves to define our own sorting. Let's go back to the example. So by passing these variables to the block, we can define how sort should compare each of the pairs inside our array. Then it uses an algorithm called quicksort to determine what the resulting array will be. As you can see, I've sorted the values in my array by the length of each string in ascending order. If I wanted to sort it by descending order, I could simply reverse the order of the operands. That is to say, b.length, comparison operator a.length. Now that you've seen an example of a block with two arguments, we can use that with each with index. Think back to the each method in our previous lesson. This allowed us to do something to each of the elements in our array. It's sometimes useful to know what the index of that element was in our array. Each with index allows us to do that. The first argument to each with index will be the name of the object. So in this case, breed. The second argument will be the index itself. So when I call puts with each of these two arguments, I actually get an ordered list but note that it's cardinally ordered. Okay, now your head's going to explode. Arrays can contain other arrays. It may sound complex, but it's actually incredibly useful. So we could use an array of 2-element arrays to associate values. Let's imagine this simple example. We could store the ages of our pets against the kind of pet. So the first element of the array is a 2-element array, cat and age 13, and the second element is dog and age 9. Let's learn how to access nested arrays. We can start with an array of 2-element arrays. Dog and 1, and cat and 2. To get the first element of 8RR, I can use the square bracket operator and 0, and that will return me an array itself. Then to access the first element of that array, I can use the square bracket operator again, and that gets me dog. Or 1 will get me 1. Similarly, I can access cat with 1 and 0, and 1 and 1. This is actually analogous to a matrix in mathematics. So for this lesson, I have a couple of exercises, and I'd like you to take the time to go through these exercises in detail. Start with the string from the exercise in the previous lesson. The quick brown fox jumped over the lazy dog. Generate a list of the unique words found in the input string, count how many times each occurs, and print them. You should also number the lines of the output as follows. In this exercise, it's important to remember the difference between cardinally indexed objects and ordinally indexed objects. In part 2, I'd like you to modify your code so that you can sort the unique words by the number of occurrences in descending order. Put another way, this is kind of like a histogram word count. So you want to list how many times each word has been found. Good luck, and we'll go through a solution in the next video.